Yeah, welcome to the class, students. We are going to learn about numbers, the number system, the classification of numbers, and the different notations used to denote these numbers, the sets of numbers. So first we will start with counting numbers, which are starts with 1, 2, 3, and it goes on. And there is actually, you can go on to a million and any large number that you can think of. Include the number 0 to this set and we get the set of natural numbers. So we can write the natural numbers as 0, 1, 2, 3, etc. and it is denoted with the capital letter N. We use this notation to represent this set. And what is the next set of numbers? The next set of numbers is the integers. This is just a recap of what you already know. So we are just learning about integers. Integers include negative whole numbers also. Negative whole numbers. Now, how do we denote this? We denote this using the letter Z. And usually we write it with a double stroke, that Z, and this is listed as 0 plus or minus 1 plus or minus 2 and it goes on. So actually if I expand it and write, it's like this. We do not know what the smallest integer is. You can think of any smallest integer and then maybe we can have, I can start with negative 3, negative 2, negative 1, 0, 1, 2, 3 and etc. So in the set of integers, you cannot actually pinpoint which is the smallest integer or which is the largest integer. Okay, it goes like that. And you can see here that all the negative numbers are less than 0 and all the positive numbers are greater than 0. Next, what is the next set? We include fractions and we also include negative fractions as well as positive fractions. And this set of numbers, the fractions, they are called rational numbers. And what is the notation for rational numbers? It is the Q, the uppercase Q. And it is of the form P by Q. P divided by Q, where P and Q are integers. So P can be positive integer, negative integer, Q can be a positive integer, negative integer, but make sure that Q is not 0. P can be 0, but Q cannot be 0. So we write that the set of rational numbers is denoted by Q, P by Q. P and Q are integers. And Q not equal to 0. So that you need to specify, and you should also know that you cannot divide by 0. And you'll be wondering why we give this name rational to these numbers. Rational, as you can see, it includes the word ratio. So we are comparing P and Q, ratio. Here we are taking the ratio of P and Q. And the Q also stands for quotient. That's the reason we are denoting it with Q. So stands for quotient, the numerator divided by the denominator. Okay, so some more about rational numbers. Every rational number can be expressed as a decimal, a terminating decimal, or a repeating decimal. So if you have this decimal, say 3.17, it can be written as a fraction 317 divided by 100, where 317 is your P and 100 is your Q. So 3.17 is a rational number. Now what about 0.333 This is a repeating decimal or a recurring decimal. So this is denoted sometimes in short, we put a dot over the 3. Right. Now, you will also be learning that the recurring decimals can also be converted into a fraction. You will be learning this a little later in another section. Can be represented as a fraction. Okay, so now we have expanded our number system from natural numbers to integers to rational numbers. Now we have another set of numbers called irrational numbers. Now what are these irrational numbers? In the decimal form, they neither terminate nor do they repeat. So I can give you a decimal example for this. Say for example, I have 0.17325 0.039 and it goes on. See, you can see there is no pattern in the decimal representation, nor does it terminate. It goes on endlessly. So these type of numbers are called irrational numbers. And also, if you take a square of side 1 unit, and if you consider the diagonal, you are familiar with the Pythagoras theorem, the diagonal's length. What is the diagonal's length? It is given, you can use the Pythagoras theorem and get the diagonal's length. So d squared is equal to 1 squared plus 1 squared. And d can be square root of 2. And this square root of 2, even if you use your calculator or the other methods, the division method, you will find that this 2 will have a decimal representation which does not repeat, which repeats endlessly but has no pattern. It doesn't terminate. So here root 2 is an example of an irrational number. And there are several irrational numbers. Root 3 is an irrational number. Negative root 5 is an irrational number. But what about square root of 25? Square root of 25, as you know, the square root of 25 is 5, which can be written as 5 by 1, a fraction. So this becomes a rational number. So any number that can be written as a fraction is a rational number. And any fraction will be of two types, either a repeating decimal or a terminating decimal. And we will learn about this representation in another section. So now let us give a visual representation of all these sets of numbers. So we started with the smallest set, which is the set of natural numbers. Then we expanded this set to the integers, and that expanded further to rational numbers. Then we have the irrational numbers here outside these three circles, and all these I'm going to put a box around all these. Now let us just put some examples in this. For natural numbers I can write say 10. And for integers I can this 10 is included in the integers, but I can also have minus 5, then I can have minus 27. So these are examples of negative integers, and 10 is an example of a positive integer. What about 0? 0 is there right there in natural numbers and also in integers. Now let us write some examples in rational numbers. So I can write this as 2 by 3, negative 1 by 5, then I can write a decimal 0.16 and so on. And then what are these irrational numbers? I have root 2 as I said, then 1 minus root 3 and so on. Even pi, you know that you use the quantity pi to find the area of circles. This pi, though we though we approximate pi to 22.7 as a rational number, or you write it as 3.14, the decimal representation of pi, they are still finding out more and more decimal digits for pi. It's never ending, it's an irrational number. It's also called a transcendental number. So I'm going to bifurcate this. So here we have the rational number, and here we have, they don't overlap, and together the rational and the irrational, these are called real numbers. Now all these are real numbers. Rational number is a real number. Integer is a real number. Natural numbers are real numbers. Irrational numbers are also real numbers. And what is the notation for real numbers? It is R. So R stands for real numbers. Now, when I say real number, every real number has a location. It can be spotted on the real number line. So the number line that we draw, it's called the real number line, and every real number, it's be it an integer, be it a rational number or an irrational number, it will always find a place in the real number line. So let us mark 0 at the center. We have 1 over here, 2 over here, then 1.5 may be here in between 1 and 2, and this square root of 2, it will be somewhere here. And how to locate square root of 2 on the number line, that also we will be studying later on, how to locate irrational numbers on the number line. And that's a very interesting topic, how to locate irrational numbers on the number line. So that sums up the number system.